Hey there, Advanced Math. We are going to talk about inequalities today. They're very similar to equations, but just slightly different. So label your next page for me. Inequalities. Strategy number 1, common sense. Same as we use for equation strategy 1, common sense. It's a good way to get you introduced to inequalities and kind of get started. All right. So speaking of, here's a quick equations example I want to go through. We learned 3 strategies for equations. I want to review them because inequalities work very similarly. So this Mike needs to read for 30 minutes. He's read for 12 so far. How many more does he need to read? So we set our equation up in a situation kind of like this. The total time was 30 minutes, and that's my first expression. And it's equal to another expression, which is the 12 minutes he's read so far, and however many minutes he has left. I'll call that M. And we set up like that. So our first strategy was common sense. It was just to say, well, I can look at this and I just know what that has to be. 12 plus 18 equals 30. Easy enough. So that was one strategy we used. Another was visual. So okay, well I can draw that. I can say, all right, he needs to read for 30 minutes. There's my whole reading time. And he's read for 12 so far. The remaining time is M, and I could figure out what that needed to be from my visual. M equals 18. Third one was inverse operation, where I could say, okay, that is M, what's happening to M, and it's having 12 added to it. So I'm going to do the inverse operation, which is to subtract 12 from this side and subtract 12 from this side, and then 12 minus 12 is 0. So I get M equals 18. And in all 3 cases, I got the same thing. So we're going to do a slightly different situation than this today. So this was Mike needs to read for 30 minutes. I'm going to change the situation ever so slightly. Ready? To this. Mike needs to read for at least 30 minutes. Instead of he needs to read for 30 minutes, I'm going to add some words in there. He needs to read for at least 30 minutes. So far he's read for 12. How many more minutes does he need to read? So, this is the same question. We said last time it was, well, expression number 1 is 30 minutes. That's what he needs to read. And so expression number 2 is what he has read. And that was 12 plus M. But in this case, this is a little different. Instead of these needing to be equal, these don't have to be equal anymore. Because he doesn't have to read for 30 minutes, he has to read for at least 30 minutes, which means he can read for 31 minutes, 32 minutes, 33 minutes, 34 and a half minutes, 36 and 1/4 minutes. Anything that's greater than 30 minutes will be okay. As long as what he reads is more than 30 minutes, he'll be okay. Here's how we write that. I'm going to write that as this, the 12 plus his minutes, needs to be more than 30 minutes. Or actually, at least means it can be greater. Or it can be equal. If he reads for 30 minutes, that's still okay. So in addition to being greater, we have a sign where we write that it can be greater or equal to 30 minutes. And it looks like this. We make the greater than sign, and we also put like half an equal sign underneath it. So this is going to be my new expression here. So in this situation, instead of needing to read for exactly 30 minutes, this can equal 30 minutes, equal, or this can be more than 30 minutes. So I'm going to say greater than or equal to 30 minutes. So now I'm thinking through all of the different numbers of minutes that he can read. And we're going to represent this in a certain way. So I'm going to use a number line to think about this as my common sense strategy, kind of, right? We already know I'm going to start like thinking about numbers of minutes that he can read. And I'm going to start kind of like, I know 18 from the last question, 18 is kind of a magic number here, right? He has to read at least 18 minutes. That's kind of common sense to me. I know if he reads 18 plus 12, that'll equal 30. That's okay. So I'm going to put that like right in the middle. I'm going to say, okay, well, he can read for 18 minutes. He can also read for 19 minutes. He can also read for 20 minutes. He can also read for 1 minute. It's all okay, right? And on and on. As long as he's more than 18, he's okay. If I go back this way, 17, not okay. 16, not okay. 15, not okay. 14, not okay. And so on and so forth. So what I do on my number line, if we were just showing 18 on the number line, we would just do this. We'd just say, okay, 18's okay. But here he can read 19 minutes, that's fine. Or 20. Or 21. Or 22. Or 23. Or anything in between 18 and 19. 18 and a half, 18 and 3/4, 18 and 59 seconds. All of this is okay. All of this is okay. All of this is okay. So I'm going to shade in any number he can possibly read and be okay. And I'm just going to kind of shade all this in. When I get to 18, since that's the lowest one, that's okay. I put kind of like a big dot there. But above that, I just shade it in. And actually, more than 23 is okay. And on and on and on. So I write the answer like that. I say anything I've shaded orange is okay. Basically, M can be any value that is greater than or equal to 18 minutes. I've shaded in 18 that's equal, and I've shaded in everything that's greater than 18. And so it works just like an equation, except I don't just have 18 like I did before. I can have like a whole lot of stuff related to it. Let me do another one. So I changed it even slightly more. This said he needs to read for at least 30 minutes. This said he needs to read for more than 30 minutes. Very similar situation. Except now, the only difference is now 18 minutes on the nose is not okay. 18 is still kind of my magic number here. More than is a little different than at least. At least means 30 minutes is okay and anything more is okay. More than 18 is not okay. So I'm going to shade that. I'm going to make that look slightly different. Check it out. I'm going to do 18, 19, 20, 21, and so on. 17, 16, 15, and so on. And now when I think about all the things he can do, everything greater than 18 is okay. Except, so it's kind of like this is all okay. This is all okay. 21's okay. 20's okay. 19's okay. 19 and a half's okay. 19 and a fourth is okay. 18 minutes and 1 second is okay. But when I get to 18, it's not. So what I do to show that is I'm going to put a circle around 18 to show that I'm not shading it in. Here I put a circle around it and did shade it in because it was okay. Here I'm going to go right up to it, but I'm not going to shade it in because 18 is not a possible solution. So in this case, his minutes can be anything greater than 18, but it can't be 18. All right, let me do one more. Totally different problem. Twix costs 50 cents at the gas station. How many Twix can you buy for $10? So I'm going to write my inequality first. So expression number one, I've got $10 and 50 cents. I can spend 50 cents times however many Twix I want to buy up to $10. Oops, not equals though. That's my, well, let me go back to that. So on the one hand, I've got $10. On the other hand, I've got 50 cents times the number of Twix I can buy. 1 Twix, 2 Twix, 3 Twix, 50 cents per Twix. So now I need a sign between these. So I can't spend more than $10. So what I spend is going to need to be less than $10. But it's actually also okay if it's exactly $10. That's fine too. So I'm going to say this needs to be less than or equal to $10. So when I map that out, So I'm going to go common sense here, right? So if it's 50 cents, that means I can buy 2 for $1. I already know the max I can buy with common sense is going to be 20 Twix. So that's kind of my magic number here. I know 20 is my limit. So I think I can do less than that's all going to be okay, and so on. More than that's not. It's going to cost too much. So what I'm going to do is I'm going to say, okay, well, I'm going to shade in what's okay. I can buy anything less than 20. 18, 19, and 20 is okay. So when I get to 20, I'm going to circle it. That's my kind of my magic number, my max, and I'm going to shade it in because to show 20 is okay. So the number of Twix I can buy needs to be less than or equal to 20, and I won't overspend my budget. Okay? All right, open your math notebook. Let's do one or two together here. Dr. Dober wants to finish a race in under 1 hour. So far, he's run for 45 minutes. How many more minutes can he run to make his time? So we need to talk minutes here. 45 minutes and 1 hour is 60 minutes. So my total time here is 60. That's my first expression. And I've done 45 plus whatever I have left. I'll put rest, R for rest. And now I want this in this situation to be under 1 hour. That means I do not want my time to be 1 hour. I want it to be less. So my total running time needs to be less than an hour, but not equal. So I'm not going to shade it in. I'm not going to put the equal sign, because if I do that, I don't want to run 1 hour. I want under. All right, so a little common sense. I can already tell 15 minutes is going to be my max. Just a common sense. If I run less than 15 minutes, I'm good. More than I'm not. So I'm going to put 15 here in my number line. Say 16, not okay. 17, not okay. 18, not okay. 14, okay. 13, okay. 12, okay. And so on. And I'm going to shade all my okay times. I'm okay with anything over here. I'm okay with 12 minutes. I'm okay with 13 minutes. I'm okay with 14 minutes. I'm okay with 14:30, 14:40, 14:50, 14:59, all okay. As long as it does not take me exactly 15 minutes. When I get to 15 minutes, I do not want to run that, so I will not shade it in. Because if I do that, I'd have 60 minutes, and that's not less than 60 minutes. So that's how I'm going to write it. So I can run anything that is not equal to any number of minutes that is less than 15 is okay. So that's my solution to my inequality. I can run anything less than 15. One more. I'm going to have to go fast because I'm almost out of time. Dr. Dober wants to run at least 5 miles. Each lap around the park is half a mile. How many laps should he run? So on the one hand, I have 5 miles for my first expression. And the other hand, I have half a mile times however many laps I'm going to run. I don't like to use L because it looks like a 1. So I'll do half times C for circle instead of lap. And I don't care how long, as long as I run at least 5 miles, I'm good. So this can be more than 5 miles. Or it can be exactly 5 miles, and I don't care. So if they're half a mile each, I know that I need to run 10 laps, common sense, or more. And I'm almost out of time, so I'm gonna pause, and my number line is just gonna appear. So there's my number line, and I'm okay as long as I get 10 miles or more. So 14, fine, 13, fine, 12 laps, fine, 11 laps, fine, 10 and a half laps, fine, 10 and 1/100th laps, fine, and actually, at least means 10's okay. So when I get to 10, I'm gonna color that in, because 10 is also okay. So I am just about at the end of my time. This is a tough concept. I can run greater than or equal to 10 laps. If you need to go back and watch any of these examples again, please, 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 please do. Please come to class tomorrow ready for this new concept and kind of tough. All right, see you tomorrow.